Hello and good evening, and welcome to this video tutorial on how to automate with the bash shell the calculation of your EIGRP composite metric. And so as you can see here, I had a student recently request an easier way to calculate the EIGRP metrics as opposed to having to use a calculator or to try to do the math by hand. And so I went ahead and demonstrated a quick bash shell script here, and so I'm going to leave this up on the screen as long as I can. I'll be moving back and forth between the secure CRT window as well as showing you the diagram here, but I'll leave this up on the screen. If you wanted to pause, and this is the entire script right here with comments, so if you wanted to pause and then recreate the script, now would be a very good time to do that. Before I start moving back and forth between the different windows. But first, I'm going to go ahead and walk you through the code that we have here. So remember that we have the magic number, and the magic number is followed by the absolute path name to the shell that you want to interpret this program. And so the reason that we place this up here is that if a user, whoever the user is who's running the shell script, the shell that they're using as their login shell that they're currently logged into, that is going to be the shell that's going to try to interpret the code in this script. And we have some very specific bash shell syntax here, specifically when we get into the mathematical equations, that require that the bash shell interpret the script. And so by placing the magic number here followed by the absolute path name to the shell that we want to interpret this script, this means that irrespective of the shell that the user may be using, so let's say the user's logged in and they're using the TC shell, or maybe they're using the C shell, or the Z shell, corn shell. So irrespective of their shell, this line right here says look in user bin and use the bash interpreter, the bash shell, to interpret the contents of this script. And so by doing this, we kind of have a little safeguard here that even if the user is not using the bash shell, that the bash shell is successfully going to be called and they're not going to have to convert this into a different language, so a different shell language. All right, so the first thing we do here in the pound signs at the beginning of the line, you only need one. I like to put two. It's just a convention I've always used. So, but you could simply put one, and this just means comment. So anything that follows these hash signs here, these pound signs, is a comment. And so my first comment is, let's prompt the user for their K1 bandwidth and K3 delay values. So I like to clear the screen. It's something I've always done. I like when I run my scripts, I like the screen to be clear so I can see the output all by itself and not with a whole bunch of other other junk on the screen. So we use the echo command, and the -n, what this is going to do is after it echoes out this statement, it gets to the very end right here, the cursor is going to wait here for your input, or I should say right there. The cursor will wait for your input because of the -n, right? If you didn't do this, the cursor would show up on the next line. And so I always like to have it here at the very end along with the prompt that you're being asked to respond to. Now the next part, this is where we're going to read in, right? We're going to read the user's input, and I'm going to go ahead and use the convention I've always used, which is I always begin my variable names with an underscore. So underscore K1. So whatever the user enters in here, and it's going to be the slowest outgoing interface in kilobits per second, because remember, when we're calculating that EIGRP composite metric, we pick out of all the outgoing interfaces along the path, we're going to pick the slowest bandwidth interface, right? It's not cumulative here. It's simply the slowest interface bandwidth of all the outgoing interfaces from the start of our path to the end of our path. And we're going to read in whatever that user enters as our underscore K1 value. And then the next set of code, very simple, right? We're going to say enter your K3 value, which is going to be your delay. And we're asking for the cumulative path delay in microseconds. And we are using the underscore K3 when we read in what the user enters here. All right, so now what are we going to do? So let's convert the K1 and K3 metrics. So remember that with the bandwidth, we take 10 to the 7th, right, as our reference point for the bandwidth, and we divide that by the slowest interface in kilobits per second. And so we precede our variable, which is underscore K1, with a $sign here, because this is how we elicit the value, right? This is how we tell the bash shell that I want you to now use this value that the user entered in up here, right? So whatever the user entered in up here, that value is now going to be put into play, and we're simply going to use that value to divide 10 to the 7th, I'm sorry, to basically divide 10 to the 7th by that value. And that's what this syntax here will do for us. Now, we're also creating a new variable over here, and I just put the underscore C for converted. So underscore C underscore K1 is going to, and the equal sign means it's going to be assigned the result of this equation. So when it's all said and done, underscore C underscore K1 will be assigned, right, or will equal the result of 10 to the 7th, 4, 5, 6, 7, divided by whatever the slowest bandwidth is. And this is the variable $sign underscore K1, right? And then the same thing here for our delay value. So I have underscore C underscore K3 is going to be assigned the result of this equation. And so again, we call the value of the variable underscore K3 because we need to use it now, and we're going to divide it by 10. And so again, underscore C underscore K3 is simply assigned whatever the result of $sign underscore K3 divided by 10 is. And so we have two different variables that we're going to be dealing with here that we've just created and or instantiated. And so what are we going to do next? So now we're going to add the results of the K1 and the K3 values together, because in the EIGRP composite metric calculation, that's what we do. So I'm going to instantiate another variable here called K1 underscore plus K3, right? Very descriptive, so that you know we're basically adding K1 to K3, and this variable is going to be assigned the value that is returned when this mathematical equation is run. And so these variables here should look familiar. We just created those guys right here. And so now we're just bringing them down here, and I'm just adding them together. So then finally, I'm going to take the sum, which was this equation here, of the K1 and the K3 values, and we're going to multiply by 256. And this is the final step in the EIGRP composite metric calculation. So I create one last variable, and it's going to be called underscore EIGRP underscore metric, and it will be assigned the value that results from this equation. And again, you probably could have done this with fewer variables. But the reason I did it out like this, it's almost kind of like longhand, is sort of to do it in a logical fashion. We might have a couple extra variables that have been created that we could have saved. But again, it's to walk you through each of the steps, and hopefully this makes some logical sense instead of throwing up some extremely cryptic code in order to save a variable or two, when really the goal here is to get you to see and to understand how you can use the bash shell to do calculations like this, and more so that you can see how each step, we're kind of moving along in each step. So we get to see some addition, we get to see some division, we're seeing some multiplication now here at the end. So I literally take the K1 plus K3 and multiply by 256. And then I'm simply going to echo out your EIGRP path metric will be $, because now I need to see the value, right? This variable right here is this guy right here. So when I want to see the value, I need to precede the variable with the $, and that tells the bash shell that you're going to give me the value that is assigned to that variable. And so if all of this code is correct, we should be able to punch in the slowest outgoing interface in kilobits per second and the cumulative path delay that's displayed for us, and this shell script should auto-magically tell me what my EIGRP composite metric will be before I even do a show IP route. So now, where might this script also have some serious value is if you're thinking about doing some layer 3 traffic engineering, some EIGRP traffic engineering, and you want to model what that EIGRP composite metric is going to look like. And so we'll take a look at that here in a second. So let's go ahead and take a look at our EIGRP topology here. And we have our 4 routers, router 3, router 5, router 4, and router 6. And so from router 5's perspective, let's go ahead and do a show IP route. Or actually, before we even do that, we'll do a blind test here to make sure that the script is doing what we anticipate it's going to do. So I want to see what the metric will be from router 5 over to the loopback on router 6. And so this is going to be our destination, right? This will be my destination here. And this is going to be my source. And we're actually going to go this way here, I can tell just by looking, because we have this serial. This is a serial link in here, right? So this is very, very slow. So we're probably going to come this way because we have one outgoing fast Ethernet interface, we have a second outgoing fast Ethernet interface, and then finally we have an outgoing loopback interface. So there's 3 things that we need to look at in order to get the variables that we're going to put into our equation. And so let's take a look on, from router 5's perspective, let's do a show int on FA00, and let's see what the delay and the bandwidth are. So as you can see, we've got a delay of 100. So we're going to go ahead, I make a small note of that and just simply say for fast Ethernet interfaces, it's 100. But we're going to check each router just to make sure. And then we've got the bandwidth is at 100,000 because again, these are all fast Ethernet links. So if I say show int FA01, you can see that we have, again, a delay of 200. So now the delay is 200 because remember, it's the cumulative delay. So each of these outgoing interfaces, I'm going to go ahead and just simply continue to add them together. This is very different from what I'm doing with the bandwidth. With the bandwidth, I'm simply looking to see, is this interface lower than the previous interface? And it's not, it's the same. All right, so one last check on router 6. Let me go ahead and say show int loopback 0. And let's see, so what do we have here? Actually, went the wrong way. Let's see, 1, 2, 3, 1, 2, 3. So we have 8 million. So 100,000 is definitely slower than 8 million. So now we can conclusively say that from all of our outgoing interfaces along the path from router 5 to the loopback on router 6, the slowest bandwidth in kilobits per second is 100,000, right? Slowest interface speed's 100,000. All right, so now the delay, we have 5,000. So we had 100 and 100 and 5,000. So let's go ahead and let's give our script an opportunity here to show us, and let me clear the screen here real quick of those stray marks there. So let's give our script here an opportunity to show us, can it successfully calculate the EIGRP composite metric? So the first value that we're going to enter in here is the K1 value, and this is going to be the slowest outgoing interface throughout the entire path. So we've already determined that that's 100,000, right? 100,000, which is 100 megabits per second. So I hit enter, and now we get prompted just as we had written the code to do, and it says please enter your K3 value, which is the cumulative path delay in microseconds. So I'm going to say cumulative, we had 5,200. I'm going to hit enter, and the mail there, this is not part of the script. It just so happened that there's some cron jobs that are running here, so that's why that popped up there. All right, so what we're interested in is that composite metric right there. So according to the script says that our EIGRP composite metric is going to be 158,720. Let me go to router 5, and now let's type in show IP route to see for the EIGRP learned route, and it is going via the successor 192.168.35.3. There is my feasible distance, right? So it looks like the script is functioning, but let's make this a little more interesting. So what I'm going to do now is I'm going to go ahead and I am going to take down the FA00 interface here, and I'm going to force the traffic from router 5. I'm going to force it to go over the serial link to get to the loopback of router 6. And then as the final test, we're going to force 5 to go over the serial link to 4 to 6, and then around to the loopback of 3. Because we're, again, taking this link down, 5 is not going to be able to go to the left here across the 192.168.35 transit network. All right, so let's go ahead and take that interface down. So we're going to say conf t interface FA00, and I'm just going to simply say shut. We're going to lose our IPv4 and our IPv6 adjacencies with router 3. And so now, what is the bandwidth and the delay going to look like when I'm forced to use serial 010? So if I were to say do show interface serial 010, you can see now we've got a little larger number here in terms of our delay. And look at the bandwidth, right? This is definitely a departure from 100,000. So, excuse me. So the bandwidth is going to be 1544. And just by looking at the next hop that we're going to take, the next two hops, I should say, you know, the 192.168.46 transit network and then out the loopback interface, we've already seen what fast Ethernet interfaces look like. There's no doubt that 1544 is going to be the lowest outgoing interface bandwidth along our path here. So really what we're interested in right now is the delay. So let's go ahead and let's annotate the delay at 20,000 microseconds, right? And then I'm going to jump on router 4, and we have not been to router 4 yet tonight. So let's do a show int FA00 to confirm that we should see 100,000 for the bandwidth, and we see 100 for the delay. So the 20,000 delay, I'm going to add 100 to that. And then our final jump we've already seen, and so these numbers will be the same here. And yes, 8 million is definitely larger or greater than 1544. So, but we need this delay, right? Remember, cumulative delay. And so again, if we're looking at this, I'm looking at the outgoing interface, which is going to be that interface right there, serial 010, this interface right here, and then this interface. And again, the loopback interface is an interface, right? We can see we have the bandwidth and 5,000 delay that we need to take into account here. So let me go ahead and actually let me just back those guys up, and we're going to say, let me come back over here now. So we've got 5,000. So basically 25,100 is our cumulative delay. And that cron job's running there. I'm trying to make sure it doesn't interrupt us here. So we're going to enter our K1 value. So what is the slowest bandwidth, right? It was 1.544 megabits per second, which in kilobits per second is 1,544. And then how about our cumulative path delay in microseconds? Well, we had the 20,000 for the serial link. We had the 100 for the fast Ethernet interface. And then for the loopback interface, we had to add in 5,000. So that was 25,100. All right, so our script is telling us that our EIGRP composite metric, when we have to come across that serial link, is going to be 2300416, or 2,300,416, which you can clearly see this is why the path, this path was not chosen by R5 when the fast Ethernet interface on R5 was up, because that metric was only 158,000, I believe. What was that? Yeah, 158,720. Okay, so the script is telling us that our EIGRP composite metric is going to be 2300416. Let's go ahead on router 5 right now and say do show IP route. And we are looking for the EIGRP learned route here. And as you can clearly see, our successor is now 192.168.54.4. This is router 4, and as you can see here, this route's only been in the routing table for about 4 minutes and 4 seconds because it was newly inserted after we took that fast Ethernet interface down. And most importantly, here is our EIGRP feasible distance, our metric 2300416, right? And that actually matches our EIGRP script. All right, one final check now. We're going to do the maximum number of hops we can here in our environment. So we're going to go from 5 to 4 to 6. Let's see. Whoops, and I did not want to do that. Let's see what our metric to 3333 is going to be. We can actually see it here, 2,302,976. However, let's go ahead and walk the path, and we actually don't even need to pull the interfaces up because we have the values already. So we know right now, and I'll draw these up here on the screen, that for the serial interface, we're looking at a delay of 20,000, right? And the speed is 1.544 or 1544 kilobits per second. So that is definitely, you can just tell by looking, we have fast Ethernet interfaces everywhere except for here. So that's going to be my slowest bandwidth. All I need right now is the delay of the outgoing interfaces. So we know this interface here is going to be 100. We know that outgoing interface there is going to be 100. And we know this outgoing interface here is going to be 5,000. So what do we have? 25,200 as our delay. And our slowest bandwidth of any outgoing interface is 1544 kilobits per second, right? So let's go ahead and let's plug these numbers into our script. And let's see if our script is going to work for us one final time. And I'm trying to make sure that mail thing doesn't pop up on us again there. So the slowest interface is 1544. The cumulative path delay in microseconds is 25,200, and that gives us 2,302,976. Let's do a quick check here. 2302976. All right, so it matches up perfectly, and it's matched up every time. So what you could do with this script if you wanted to, let me bring the interface on R5. Let me say no shut, and we'll bring that interface back up. And let me save, make sure I save this config here. All right, so my adjacency should reestablish. There's the IPv6 adjacency coming up, and then the IPv4 was above it there. All right, so we have all of our interfaces back. If I said show IP route, you're going to be able to see now that to go to 6.6.6.6, that the successor, and here we go, it's only been in the table for 11 seconds because remember, this link just came back up. So, and there is our EIGRP composite metric that we saw the first time we ran the script. So here's what you could do with the script, right? If you were interested in seeing what the change would be, what the metric is going to be when you make changes. Let's say that you want to tweak the bandwidth on an interface, or you want to tweak the delay on an interface. So if we were looking at this, right, we know, and we actually know from show IP EIGRP topology table, and we're going to have to do for 6666, we're going to have to do, or we're not, I'm sorry, it is the feasible successor, right? So here's the feasible distance, right? And you can see here that this is lower than this. So this number here, right, is lower than the current successor's feasible distance. So therefore, this meets the feasibility condition, and this is a feasible successor. So it's already pre-staged here in the topology table. So when the link goes down, and we demoed this the other night doing some ping testing, you'll see that the route gets inserted rather quickly. We only missed 2 pings into the routing table, and then traffic continues just as it did before. So what would we have to do if that is the number there, and that number there we saw earlier over here, if I'm not mistaken, right? So this is going to be the metric, okay, the feasible distance. This is going to be the feasible distance if this route gets inserted into the routing table. So if that's the current metric, what would we have to do to tweak this to make it like 1 or 2 more higher than this, greater than this number here, to basically switch the paths, maybe using delay or some other metric? So if we were to go ahead and let's rerun the script here, so I can model this. I can say, well, what if I were to say that, what if I were to come onto the FA00 interface here and change the bandwidth to 128, and the cumulative delay, I go ahead and leave at, and we know that it's going to be 100, 200, so 5200 and 5200. What would the metric be then? So it would be 201, 33120. So let's see. No, that would still be less than this, right? So then we would still be going out to router 3 as our successor. What if we were to tweak it down, and let's say I made it 64 kilobits per second, and we've got that same 5200 delay. Well, now we've got a much larger number, so let's make that change. Let's see if that is correct. So we're going to say config T interface FA00. Oops, and I'm going to say, don't want the autonomous system number. So what we're going to say is, not the bandwidth, I apologize. So if I were to change the delay, and you can see it's tens of microseconds, right? So let's go ahead and change the delay. Or I'm sorry, I was tweaking the bandwidth. I'm going to tweak the bandwidth. So if I tweak the bandwidth, sorry about that, the bandwidth to 64, let's see, does that change which route for 6.6.6 gets put into the routing table. And take a look at that. So by changing the bandwidth on the interface, I was able to model and get, much larger than, but I was able to figure out, okay, how could I get to the point where my metric is going to be higher because I've tweaked the bandwidth on that interface. So now I'm going to say no bandwidth 64. Let's take that off of there. And a good rule of thumb is that you typically don't want to use the bandwidth. So let's go ahead and let's adjust the delay, because remember, the bandwidth, it's simply going to pick the slowest interface along the path from all of the outgoing interfaces. And when I do that to the bandwidth, to the interface, by changing the bandwidth, I could be affecting QoS, I could be affecting other things further down the path. So bandwidth is typically not a very good metric to adjust with EIGRP for those reasons, as well as a number of others. So now if I say do show IP route, look at that. So now we're back, right? So again, if I do the do show IP topology table, do show IP EIGRP topology table. All right, so what's our number here? So let's see how close we can get to this number. So 2300416. So I'm going to go ahead and we're going to leave the interface speeds, right? It's going to be 100 meg the whole way as the lowest speed. And then now let's tweak the delay. So the cumulative delay was 5200. What if I put it at 100,000 as well? So then I end up with 2585600. So let's see. What do I have here? So yeah, that's pretty close, right? And it is greater than. So if I tweak the delay on this interface by saying delay, and I put it at 100,000 and hit enter and do show IP route, what happens? So there's my traffic engineering. So by simply either adjusting the bandwidth, which again, let me highlight, that is not the recommended approach. You would want to tweak the delay like we just did there, or by tweaking the delay like you just saw, I'm able to simply do traffic engineering by getting EIGRP to take the route that I wish it to take. Now again, if we take a look over here, it might not be that this is the best decision. However, for demonstrative purposes, this is a very simple topology. It's very easy to see what we're doing. So we simply changed the bandwidth and delay here, right? We did the bandwidth first, and now we just did the delay. And so we made the delay so bad that EIGRP quickly realized, you know what? Coming this direction is not what we want to do. So again, we tweaked the delay here, and EIGRP said, you know what? Now when I go this way, the cost is greater than the feasible successors, what his metric would have been. So it recalculates it and says, you know what? It looks better if we go this way. Because again, the EIGRP metric was lower going this way after we tweaked the delay. And so that's one thing where this script could be very handy, right? If you wanted to see just how close you could get to that number, so let's say 95,000 for the delay. Now we're even closer. So where are we at here for 6.6? So 2300416. Now we're at 245700. So you could even drop the delay further, right? And let's do one more, see how close we can get. So we're, again, remember, the slowest interface, outgoing interface along the path is still 100 megabits a second. And then we're going to drop it to 90,000. So the cumulative delay, or I should say the delay on this interface, which gets added into the cumulative delay. So 23296, that's pretty close. What do we have here? 23, yeah, so that's extremely close, right? So, but it's still this number over here is greater than, so if I were to say, let's pull that bandwidth command or the delay command back up. If I said no delay 100,000 and I do show IP route, what would we expect to see? Exactly what we're seeing. EIGRP is now saying my successor is router 3 because the metric going that way is 158,000. But again, let's tweak the delay and now let's put it at, what did we say, 90,000? So let's put it at 90,000 on that interface, right? So we're placing that delay value on the FA00 outgoing interface, and now that 90,000 is going to get added into the other delays along the path of all the outgoing interfaces. Do show IP route, and we should see 232.9600 and and has it not? Oh, I'm sorry. We're not going to see. That's higher than. We're not going to see this because it's greater than. If I do a do show IP EIGRP topology table, and we're probably going to have to do. We don't even have to do the all links. So 232. Yeah, it's not going to show it in here either. But that's what it would have tweaked. Oh, sorry. That's what it would have changed it to. So, and again, we're checking to see, hey, is this going to be greater than the route that we had as our backup? And so again, by changing the delay, we're able to influence the flow of the traffic. Is the traffic going to flow to the left to router 3, or is it going to flow to the right to router 4? And again, by increasing the delay on that fast Ethernet 00 interface on router 5, we are making this interface right here, and specifically the path going that way, less desirable than coming across the serial link. All right, so that wraps up this video tutorial, and let me go ahead and clear the screen here, and I will cat out the script and leave the script up here as well. And so again, a very simple script, and one that I hope that you get some value out of, that will allow you to model the EIGRP metric, and to basically calculate what the metric is going to be along your path without having to bust out a pencil and paper or a calculator. You can simply input your information into the script, and it is going to kick back to you the correct value, as we've seen multiple times here. So I thank you for watching. I hope that you get some value out of the script, and have a great evening.